Alright everyone, in this video I'm going to show you how to predict movie ratings with the k-nearest neighbors method. Now why would we want to use it? Well, its purpose is to use a database in which the data points are separated into several classes to predict the classification of a new sample point. So the algorithm is find the k number of nearest neighbors based on your given distance metric and let them vote on the class of the new point, or for a regression situation, you want to take the average of these neighbors' values to arrive at the predicted value. So that kind of summarizes what we're doing with k-nearest neighbors. Now let's look into some Python code to see how we can actually use this to predict movie ratings. So to start with, let's load up our pandas data frame with the MovieLens 100K dataset. And that's what this code here does. And let's take a look at it. So you can see we've got these columns of user ID, movie ID, and rating. So user ID 0 rated these 3 movies, and so on. Now let's group by movie ID and then calculate the number of ratings and average rating for each movie. That's what this here does. And now we have a movie ID of 1 has a number of ratings of 452 and an average rating of 3.87. Movie ID has only 131 ratings and an average rating of 3.2, and so on down the line here. And now let's create a data frame that normalizes each number of ratings value to a value between 0 and 1. So 0 would be this did not get any ratings at all, and 1 would be the highest possible number of ratings. That's what this code here does. And if we look at movie ID 1, for example, we come up with 0.77. So somewhere near the top of popularity in terms of number of ratings. Something like movie ID 5, whatever that might be, has a normalized value of 0.14, so that's close to 0. Not as many ratings for that guy. And then the rest sort of fall somewhere in between. Now we're going to create a Python dictionary with each item containing the movie name, the list of genre values. So out of each of the possible 19 genres, we're going to assign a 0 if it's just not in that genre, or a 1 if it is in the genre, the normalized number of ratings, and the average rating. And if we take a look at the dictionary item for Toy Story, which is movie ID 1, we get the name, which is Toy Story here. We got the genre information, so apparently it's a member of these 3 genres, whatever those might be. It has received many ratings since it's closer to 1 than 0, and an average rating of 3.87. Now, let's define compute distance to see how close 2 movies are in terms of genre and number of ratings. Okay, that's what this function here does. And let's test our compute distance function with 2 movies which just aren't very similar, which is GoldenEye, which has a movie ID of 2, and Get Shorty, which has a movie ID of 4. And we get a distance of 0.67. So now remember, in terms of distance, the lower the distance, the closer the movie. Okay, so 0.67 does not appear to be very close, which is what we would expect. Now, let's define a function that gets the k-nearest neighbors based on this distance score and test it with Toy Story, which is movie ID 1. And here we have a getNeighbors function, which is just going to say, hey, for this given movie ID, right, let's find the k-nearest neighbors. And it's just going to return those neighbors. So if we start out with a k value of 5 and say, okay, here they are, here are the 5 nearest neighbors, and then show the average rating for those 5, we get this result. Willy Wonka and the Chocolate Factory, Aladdin, Liar Liar, Monty Python and the Holy Grail, and the Full Monty. So the average rating of the 5 nearest neighbors here is 3.71, and how close did we actually get to Toy Story's rating? 3.87. So that is very close. And if you look at these movies, they do appear to be similar, or at least in terms of rating, right? Or what people might like if they like Toy Story. So yeah, here we have an example of how we might use K-nearest neighbors to predict the rating of a movie, which is pretty impressive there. Hope you got something out of watching this video. I thank you for watching, and we will see you in the next one.